probably the simplest function and one of the most useful functions is the linear function. There are four types of linear functions. They are either increasing, decreasing, constant, or vertical. An increasing linear function, as it goes left to right, goes upward, so like this. And the steepness just depends on how positive of a slope that the function has. In this case, it's not terribly steep, so it's not going to be very positive slope, but it is an increasing slope. We'll talk about slope more in a second. The next type is decreasing. That's just whereas it goes downward as we go left to right. So g of h or g of x is decreasing function. We have a horizontal function, which is just a flat line. It doesn't go up or down. And finally, we have the last type, which is the most unusual, and that is a vertical. Vertical slope goes straight up. We'll say v of x. This is the most unusual, and you'll see why, but the other three are pretty common. Increasing is f of x, decreasing g of x, constant h of x, and vertical v of x. There are two main forms of a linear function, the slope-intercept form and the point-slope form. The slope-intercept form looks like y equals mx plus b. This is called the slope-intercept form. That's because the slope is in the equation and the y-intercept is in the equation. The point-slope form is y minus y1 equals m times x minus x1. And it's called the point-slope form because we have the slope again. And now you see y1 and x1, and that's a point on the line with coordinates y1, x1. The subscript 1 doesn't really matter. It's just to distinguish it between the variable y and x. Just like up here, we have a variable of y and x. y1 and x1 are actually numbers. They're not variables, they're numbers. Now, the most important thing you see in both of these is the slope. That's because the slope is probably the most important information on a line. And actually, the slope pretty much dictates what a line is. A line is just really a representation of the slope. The intercept is just kind of like where it's kind of anchored at in the coordinate system. But the slope is the most important. And if we don't know the slope, we need to first find the slope. To do that, we have a slope formula. And it's just, you take 2 points on a line. So we have x1, y1, x2, y2. This is the first point and second point. It doesn't matter in which order you do this, as long as you have the same order on top and bottom. Take y2 minus y1 over x2 minus x1. You can do y1 minus y2 over x1 minus x2, as long as you have the same points coordinates in each of the columns. Either way you do it, you'll get the same answer for the slope. And that's what we really care about. All right, let's do some problems with these things. So find the slope of a line passing through 2, 6 and 3, 9. Is it increasing, decreasing, vertical, or horizontal? So first off, we need to figure out what is the slope. There's two ways of course you can do this. You can do this algebraically using the formula I just showed you, or you can use this, do this graphically. The graphical representation really finds this part of the question quite easily because you can see if the line goes up, goes down, stays flat, or goes straight up. But the algebraic form gives you the exact answer for the slope, whereas the graphical, the geometric form, it's going to be a little bit harder to find the slope. So let's use the algebra to find the slope. I'm going to name the first one x1, the second the first point x1, y1, the second point x2, y2. We're going to go y2 minus y1 over x2 minus x1. That gives me 3 over 1, which is 3. Now, I can graph this. We don't need to graph this. We can actually use the slope information here to answer the second question. But I'll graph it here just to show you what the problem looks like. We have 1, 2, 3, 1, 2, 3, 5, 6, 7, 8, 9. So 2, 6 is going to go here up to 1, 2, 3, 4. This is 5, so this is going to be, there's 2, 6, and 3, 9 is going to be right here. So the line passing through these 2 points is this thing right here. And you can definitely see this is an increasing function, because it goes upward as you go left to right. That corresponds to a positive slope. This is a positive 3. Positive slope gives you an increasing function. That means if we had a negative slope, what would you think? It would be decreasing. So, on the side here, increasing function has a positive slope. A decreasing function has a negative slope. Let's think about a horizontal function. This has looks like this, right? It just goes flatlining as you go left to right. What kind of a slope do you imagine that would have? Well, as you go left to right, you do not rise anything. You just run things. Slope is really just rise over run. Equals rise over run. That's what the y2, that's what I have here. On the top here is y2 is the rise, x2 and x1 minus x1 is the run. So I can show you that here real quick. The rise is going to be up 3 units over 1 unit. That's because we have a slope of 3 over 1, a rise of 3, a run of 1. This is up 3 units, a run of 1 unit. So if we have a horizontal slope, how much are we rising? We're not rising anything. We're actually rising 0 units. So it'd be 0 over, you can just think of a run of, well, it's just like a run of 1 unit or 2 units or 5 units. It doesn't matter what's in the denominator. 0 divided by anything is 0. The 0 slope. Now if we were to think about a vertical, now we have a line like this. Here, what's the rise? Well, the rise is going to be, it can be 1, it can be 2, it can be any number on top. The run, however, is going to be 0. We're not moving left and right at all. So we have a division by 0, and you cannot do that, and so we have it said, we say the slope is undefined. It's like it goes to infinity, but infinity isn't a number, and slope is a number. So you can't say infinity. So we say undefined. That's how we describe the slope there. A little bit odd, but the nature of the division by 0. Okay. Write the point slope form of a line with slope 2 passing through 7, 2. So point slope form of a line, point slope is y minus y1 equals m times x minus x1. We know the slope and we know the point. All we really have to do then is just plug things in there and we're done. So this is x1, y1. We have y minus 2 equals 2, which is m, x minus x1, 7. That's the point slope form of the line. Really, there's no point in using the point slope form unless you get into the slope intercept form. The slope intercept form is the most useful form of a line. It's the most interesting information right off the bat. And so the next one here, you see we have write the slope intercept form of a line with slope -1/2 passing through 6, 7, 6, -7. The way we do this is we first use the point slope form and then solve for y. If we do that, we get it into the slope-intercept form. Let's first use the point slope formula. We have the slope and we have the point. So we have x1, y1. We have y minus y1 equals m x minus x1. Now all we have to do is solve for y, and we will have the slope-intercept form. So first off, those cancel. We get y plus 7. And we distribute the -1/2. Plus -1/2 times -6 is +3. Subtract 7, and we have y equals -1/2 x minus 4. That's the same thing as y equals mx plus b. So the y-intercept is -4, and the slope is -1/2. All right, write the slope-intercept form of a line passing through -3, 7, and 2, -3. The most important piece of information, the slope, is not here. So the first step we're going to do is find the slope. We need to know the slope. So the slope, I'm going to say x1, y1, x2, y2, y2 minus y1 over x2 minus x1. -3 minus 7 is -10. That becomes a plus, and we get 5 on bottom, which gives us -2. Okay, now that we know the slope, we can use either one of these points in the point slope formula. It doesn't matter. I'm just going to use x1, y1 because x1 and y1 is used in the point slope formula. It just makes my life a little bit easier. So y minus y1 equals m. Let me just show you the formula again. Right here. M times x minus x1. Okay. X minus x1 is -3. Those become a plus, and I'm going to distribute the -2 into there. Giving me y minus 7 equals -2x. That's a +3 times -2 is -6. Plus 7. We get y equals -2x plus 1. So first step there was to find the slope because we did not know it. If you don't know the slope, you need to find that. Then use the point-intercept formula, solve for y, and you have the slope-intercept form. All right, this one is the same type of problem. Slope-intercept form of a line passing through 2 points. We do not know the slope, so the first thing we're going to do is find the slope. We have x1, y1, x2, y2. We have y2 minus y1 over x2 minus x1. 0 over 7, which is 0. All right. Now, we can use the slope-intercept formula. Again, I'm going to use this point here. Point-slope formula to find the slope-intercept formula. Y minus y1 equals m times x minus x1. And you see this whole thing goes to 0 because it's 0 times something, which is just 0. Y minus 9 equals 0. Add 9. Y equals 9. Okay, let's look at the slopes and the types of functions we had here. So for this one, we knew it was increasing because it had a positive slope. For this one here, we also have a positive slope. So this is going to be an increasing function. This next one here, we have a negative slope. So this is going to be a decreasing function. This one here is also a negative slope. We have a decreasing function. And this one here has no slope, right? It should be y equals 0x plus 9. That's the slope-intercept formula. 0 times x is obviously 0, and 0 plus 9 is 9. So these are equivalent things, which means it has a 0 slope, which is a horizontal line. Now, if you have y equal to some number, that means that really all you're graphing here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and you're just graphing this flat line right at 9. That's all that's happening there. A vertical slope, let's just look at that for a moment. If we had a vertical slope, let's say, let me draw something here. Let me make it a little bit straighter. 1, 2, 3, I'll do there, -3, and just go up and down. 2 points on this line, they're pretty easy to find. You can choose really any point. You can choose, let's say, this point right here. This is -3, 4. And up here, 1, 2, 3, 5, 6, 7. This would be -3, 7. You can see that this is a vertical line. That's the way I've drawn it. Let's see what happens when we try and find the slope-intercept form. So it's a line that passes through -3, 7 and -3, 4. So first off, we're going to find the slope. We have m equals x1, y1, x2, y2, y2 minus y1 over x2 minus x1. We get -3 on top, and on bottom we get plus, and that becomes 0. And this is undefined. We cannot divide by 0. So we can immediately stop. There's no way of finding the slope, point slope form or the slope intercept form. That's because the slope, m, cannot be written as a number. So we have to, at this point, look at, since we know it's undefined, that means what we know is that all throughout these coordinates here, every single point on this line has the exact same x value, -3. Every point on this line. It all has -3 for x and then some other value for y. Which means we write this out as saying x equals whatever the x value is. In this case, it's -3. You can see that by just looking at the coordinates that are given to you. So that's how you write the equation of this line, x equals -3. It's a little weird because that's typically like a solution to an equation, or a linear equation that we have. But when we're talking specifically about this context, it's a vertical line that has undefined slope. All right, let's graph some of these linear equations. The way we always do this is we get the formula into the slope-intercept form. The slope-intercept form, y equals mx plus b, is the easiest way to graph linear functions. You can do it a lot of different ways, but that's going to be by far the easiest way. The way we do this is we first look at the y-intercept. We plot this on the y-axis. Then, so for this case, we have 3. We have 1, 2, 3. We just put a point right there. And then we look at this slope. So the slope here is 2, +2, which means we know it's an increasing function. So we use rise over run. +2 is the same thing as 2 over 1. So we're going to rise 2 units, run 1 unit. So from the 3 point that we just drew, rise 2 units, 1, 2, and run 1 unit. So up 2 over 1, that puts us right here. Now all I have to do is just draw a straight line through these 2 points. You can, of course, keep using the slope to find more and more points and be as accurate as you want, but since I'm drawing this by hand anyway, I'm not going to be able to be very accurate. So let's name this a different thing. Let's name this f of x. So I can write in here f of x. Okay, the next one, same idea. This is already in slope-intercept formula, but you see here, there's no y-intercept written, so we can think of that as +0, which means the first point is going to go right on the origin, right in the center of the graph. Now we use the slope, which is -4/5. That means instead of rising 4 units, we're going to drop 4 units. We're still going to run to the right 5 units. So we're going to go 1, 2, 3, 4, 5. Oops, it's just 4 units down. And then 1, 2, 3, 4, 5 units run. That puts us at a point right there. And drawing a straight line between these 2 points gives us something like that. And you can see how it's a decreasing function. That's because it has a negative slope, so it should be decreasing. Okay, the next two are a little different. The first thing I'm going to do is solve for the variable. Plus 12, plus 12, 6y equals 12, and then divide by 6. That gives me y equals 2. This, because no slope is written, right, we can actually write this as 0x plus 2. That means that there is no slope. It's a flat line. And the way we draw this is we look at what is the y value. It's 2, which is right here. And we just draw a flat line going through that point. I forgot to name these. Let me name this one g of x. I'll name this one h of x. So then this one here becomes g of x. And this one here becomes h of x. Now for this last one, subtract 24. Divide by 6. And divide by 6. And that gives us x equal to -4. I'm going to call this v of x because this is a vertical line and it goes through -4. So we have 1, 2, 3, -4 is right there. And there is my v of x. So positive slope, like the first one, f of x, gives us a increasing line. Negative slope gives us a decreasing line. The zero slope here, which is y equal 2, that gives us a flat line, and then x equal to -4 gives us a vertical line.